going to solve a word problem where we have to add two fractions together with different denominators. Here is the problem. Jana and Marissa are baking cakes together. Jana's cake requires 1 2/3 cups of sugar, and Marissa's cake requires 3/4 cup of sugar. How much sugar do they need altogether? The first thing we are going to do is get a rough estimate of our answer. And we're going to be using a number line to do our estimate with our benchmark numbers. I'm going to go ahead and draw our number line, start at 0, and then add in 0.5, 1, 1.5, 2, 2.5, and 3. Now, does Jana's amount of sugar, does she need more or less than 1? She needs 1 2/3, so that is more than 1. I'll put our estimate at 1.5. Now we need to account for Marissa's sugar. She needs 3/4 of a cup of sugar. Is that more or less than 1? Good, it's less than 1, so I'll estimate that at 0.5. So 1.5 plus 0.5 is 2. So our estimate is going to be 2. Now that we have our estimate, we're going to solve the problem using two types of models. The first model we are going to use is a set model. We are going to use pretzels to represent our sugar, and the sugar will be represented with a white pretzel, and our parts will be represented with a regular pretzel. So for our first fraction, we have to represent 1 2/3. So our 2/3 sugar with the white pretzel, and then our part holder, so 2 out of 3. And I'll go ahead and put our 1 of 3 parts. This will be off to the side, so we don't mix it in when we get our numbers. Now we need to account for 3/4 of a cup of sugar. So we have 1, 2, 3 for the sugar, and our 4th spot for the placeholder. So now we need to see how we can represent these. These are not equal, so we have to make them even. We need to find a number that both 3 and 4 go into. 3, 6, 9, 12, 4, 8, 12. So the number is 12. So I need to make each of these equal 12. So let's slide them over. And we have to keep our parts the same. So let's see. Here's 2 out of 3. 1, 2, 3, 4, 5, 6. 1, 2, and 3. 3, 6, 9, 12. Okay, so we need 2. So we have 3, 6, 9, 12. And we need 4, 8, 12. And then we need our parts. 1, 2, 3. Okay, so now we need to count how many parts we have all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it looks like we will have 1, because remember our 3 over here, which was 1 whole one, and then 17 twelfths as our answer. So together they need 1 17 twelfths cup of sugar. Now we're going to use a different model. Let's clear our area. We are going to use fraction strips this time in order to find our answer. So clearing this away and bringing out our fraction strips. Okay, so we know we already need 1. We're going to set our 1 to the side. We'll put it up here. But now we have to work with our fractions 2/3 and the 3/4. So let's get our thirds. We have 2 thirds, 1, 2, and we need 3/4. Let's get our 4th strips out. And this. So 2/3 and 3/4. Now, we need our number that 4 and 3 goes into, which we know from our last example is 12, that they both share. So, pulling this open, 4/12 is 1/3. So 4 and 8, because they're even there. Now, 1/4 is 3/12, and 1/3 is 4/12. So that leaves one of those left over. So we still have 1, 2. So we have 2, 3, 4, 5, 6. So with our fraction strips, we know we have 12 twelfths plus 13, 14, 15, 16, 17. So we have our 1, which was up here, and our 17 twelfths. So between the two models, we know that we were able to get the answer the same both times we did this problem. Both times we used the same math, but we saw different representations of the same fractions. We were able to see it visually both ways. Two misconceptions I want to address before we finish working are applying whole number operation rules. I expect students to do that quite a bit because they'll just add across 1/2 and 1/2 would be 2/4 instead of actually doing it the correct way. And another one is that they will not find the common denominator, but just apply a standard algorithm. For example, 4/5 plus 4/10 equals 8/10 instead of finding the common denominator.